Students were given this question: integral sine squared x cos squared x over sine raised to the power of 5x positive cos raised to the power of 3x times sine squared x positive sine cubed x times cos squared x positive cos raised to the power of 5x, and this entire component is raised to the power of 2. Now you can see that this entire question is a bit huge. So what we do is, instead of simply writing sine squared x and cos squared x, we are going to have some representation. So whenever I see sine, I will replace it by s. So this is going to be s squared, and cos is going to be c, and this is going to be c squared, divided by s raised to the power of 5 positive c raised to the power of 3 s squared positive s raised to the power of 3 c squared positive c raised to the power of 5, and this entire quantity is raised to the power of 2 times dx. Now what I wish to do is, I would like to make some changes. The changes is that I would like to divide this entire quantity by c raised to the power of 5. Now I'm going to do the division inside the parenthesis. So that will mean I would have to multiply it by c raised to the power of 10, because c raised to the power of 5 is inside and that is raised to the power of 2, and to neutralize it I need to have c raised to the power of 10 outside. So that's well understood, right? So now what I will do is, I will use the property of algebra, which is, if I were to have a positive b over c, I can rewrite it as a over c positive b over c. So by this algebraic property, I can rewrite this as integral s squared c squared. Now this can be pushed, this is actually c raised to the power of 10, right? And it is actually resting over 1. So if I were to flip it, this is going to be c raised to the power of 10, and that is divided by, as I mentioned to you, I will be dividing every term by c raised to the power of 5. So this is going to be s over raised to the power of 5 over c raised to the power of 5 positive c cubed s squared divided by c raised to the power of 5 positive s cubed c squared divided by c raised to the power of 5 positive c raised to the power of 5 divided by c raised to the power of 5. This is entirely raised to the power of 2. Of course, I've got dx that has to be placed here. So this is equal to, now I'm going to split the c raised to the power of 10 as s squared over c squared, that's one term, and then c squared over c squared, that's another term. So I got 3 more c squared, so it's going to be 1 over c squared times 1 over c squared times 1 over c squared, that is divided by s over c, that's nothing but tan, right? Now instead of writing tan, I should have written it as t, so I need to strike that a off. So this is t raised to the power of 5 positive, now this is c cubed and c raised to the power of 5, so that means I would get s squared over c squared, so that would mean this is t squared positive, now this is c squared and you got c raised to the power of 5, so that would mean I get c cubed here and s cubed over c cubed, that will be t cubed positive. This is going to be c raised to the power of 5 over c raised to the power of 5, both would get cancelled, giving me 1, and that has to be raised to the power of 2, and we got the differential operator dx, right? So we need to do some alterations like that. Now let us replace s squared over c squared as t squared. Of course, this c squared and c squared in the numerator will be cancelled. So in the numerator I got t squared times, now what is 1 over cos x. 1 over cos x is nothing but secant x. So 1 over cos squared x is going to be secant squared x, right? But we got a formula, secant squared x negative tan squared x is equal to 1. So that would mean secant squared x is equal to 1 plus tan squared x, right? So you got one positive tan squared x here and one positive tan squared x over here. So I can write it like this. So 1 positive t squared times 1 positive t squared and 1 over c squared, that's secant squared. So it's going to be secant squared x. I don't want to place it as s, because if I were to place it as s, it would mean sine. So I'm just writing it as secant squared x. So now let me first write the denominator. This is t raised to the power of 5, positive t squared, positive t raised to the power of 3, positive 1. This is raised to the power of 2. Okay, and you got this operator dx. That's fine. Now consider the denominator, t raised to the power of 5, positive t squared, positive t raised to the power of 3, positive 1. Now if I were to take t squared out, if I were to take t squared out, this would give me t raised to the power of 3 positive 1, and you got t raised to the power of 3 positive 1. I can take t raised to the power of 3 positive 1 out, and that would give me t squared positive 1. So I can write t raised to the power of 5 positive t squared positive t raised to the power of 3 positive 1 as t cubed positive 1 times t squared positive 1, right? So this is equal to integral t squared times 1 positive t squared times 1 positive t squared. That's going to be 1 positive t squared raised to the power of 2 times secant squared x divided by, this is going to be, I'm going to write this, t cubed positive 1 times t squared positive 1. This entire thing is raised to the power of 2. Of course we got the differential operator dx. So this is equal to t squared times 1 positive t squared raised to the power of 2 times secant squared x. Now I'm going to rewrite this as 1 positive t squared raised to the power of 2 times 1 positive t cubed raised to the power of 2 times dx. Now 1 positive t squared raised to the power of 2 and 1 positive t squared raised to the power of 2 can be cancelled. So this is equal to integral t squared times secant squared x divided by 1 positive t cubed raised to the power of 2 times dx. Now I can rewrite this now as tan squared x secant squared x dx divided by 1 positive tan cubed x raised to the power of 2. Now let us make this substitution. Let tan x be equal to t. When I differentiate this, I get secant squared x dx is equal to dt. So this is equal to integral t squared secant squared x dx, that's going to be dt. This is going to be 1 positive t cubed raised to the power of 2. Now this is the substitution t, right? But this is the representation for tan. So if you're not happy with this, you can change it to some other variable. So this is what we have got. Now I'm going to make another substitution. From this I'm going to make another substitution. So let 1 positive t cubed be equal to sum p. I differentiate this, I get 3 times t squared times dt is equal to dp. So from here t squared dt is equal to dp over 3. So this is equal to, in place of t squared dt, I'm going to substitute dp over 3 divided by, in place of 1 positive t cubed, I'm going to substitute p squared. It's actually p because of the degree 2. This is going to be p squared. So I move to the numerator. So if I move to the numerator, it will be p raised to the power of negative 2 dp. I integrate this. If I were to integrate this is going to be p raised to the power of negative 2 positive 1, negative 2 positive 1, which is 1 over 3 times p raised to the power of negative 1 divided by negative 1. I can push it down. It's going to be negative 1 over 3 times p. But my p is 1 positive t cubed, which is equal to negative 1 over 3 times 1 positive, but my t is tan x, so it's going to be 10 cubed x, and we need to place the arbitrary constant c. So this is a beautiful question, students, and we have achieved the result, and hence this is a good place for us to draw the red line.